Scenario: a hammer thrower traces out the following horizontal motion. Question: where in her path is the centripetal acceleration the greatest? On top of the circle, left of the circle, bottom of the circle, or to the right of the circle? This is actually a trick question because they all have the same value of AC, which is the centripetal acceleration, being equal to v squared over r. You're like, but wait, isn't on top of the circle and on the bottom of the circle differently? That is true if we were looking at the vertical direction and the circle is in the vertical direction. Here, the circle is only in the horizontal direction. Gravity has no say or effect in this way. So here, the centripetal acceleration is actually uniformed. And it's the same in every point in that circle. The next question: what is a way to increase her centripetal acceleration by a factor of 4? Well, you can do a couple of things. The first thing is you can double her tangential speed. If you do 2v naught, the squared will make that a 4. So that is also how you can increase her centripetal acceleration by a factor of 4. Or you can cut her radius by a factor of 4. So if r goes to 4, it will then you would have to multiply by 4 to both sides. That's how you can get the centripetal acceleration to also 4. So the the things that you can do are: 1, you can tell her, hey, speed up, so your tangential speed is doubled. Or you can tell her, hey, cut your radius by a factor of 4. These are all the ways you can increase her centripetal acceleration by a factor of 4.